So, hello everyone and welcome to the PcVue Podcast series. My name is Michel Kakos and I'll be your host for today's episode. Very briefly, I'm an automation engineer with 32 years of experience and I'm also responsible for business development for PcVue in North America. Today's guest is Henrik Nissen. Henrik, welcome to the PcVue Podcast series.
Thank you for having me. It's a pleasure.
Can you introduce yourself briefly, Henrik?
Yes, my name is Henrik Nissen. I am Danish. My education is as a marine engineer, so technical installations on ships. I have added that with a diploma in IT later on, but my work focus basically since university has been with automation system and SCADA systems.
Nice. Can you describe where you work, Henrik? You are currently employed at the CERN in Europe. So can you give us a little bit of a description of what that is?
CERN, which is on the border between Switzerland and France, is the European Center for Particle Research. So we do fundamental research into the building blocks of nature. So our main tools for this is accelerators that smash particles together. Just to get into CERN, it's an international organization with 30 different member states. So it's a very international work environment. So we have physicists from all over the world and we have engineers. We have actually a lot more engineers than we have physicists. So we have like 80% is engineers and then you have a last bit, which is physicists. But as I said, we use and run particle accelerators to smash particles together to find the building blocks of the universe. So our most known accelerator is the Large Hadron Collider, which is a 27-kilometer ring around 100 meters underground to shield it from radiation. And the whole accelerator is cooled down to 1 point, so it's actually cooler than out of space. So we say it's the coolest place on Earth. But at the same time, it's also one of the warmest places on Earth because in the collision points between the particles, we obtain temperatures that's higher than the sun, but in a very, 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 very tiny area. So we're the coolest place and we're the hottest place. But we do fundamental research, so we have no goal of such other than try to describe what the universe is made up of, what we are made up of. That's very short what we do.
Thank you. I think am I wrong in saying that the LHC and all the equipments, the detectors, is considered, I think, the most complex machine on Earth, if I'm not mistaken?
Yeah, complex and biggest. I think also it has been nominated as. If you see it as, we see it as a lot of subsystems because for us it's not one big machine, but they all work together, so you can see it as one big machine.
Yeah, incredible. What do you do at CERN? What's your role at CERN?
Well, I've had several roles at CERN. Just to go briefly back, so I started in the control room, in the technical control room at CERN, where we dealt with all the technical installation at CERN, so energy, HVAC, all what you would have in a big factory anywhere else. We dealt with. After that, I did maintenance databases for a while, and then I did access systems. And in the last many years, I've dealt with safety systems, so safety alarms, so alarms that are transmitted to a fire brigade for urgent intervention.
I can imagine such a huge complex, spanning kilometers, fire is an issue. So I think regarding PcVue, I think you've got an application running PcVue that does the alarm management and fire detection. Is that correct?
Yes, it deals with what we call alarm level 3. So that is anything that is personal and machine safety alarms that requires instant intervention by the fire brigade. So we got, of course, fire is the biggest. We got gas, emergency stop, emergency calls, flooding alarms. We have different categories, but fire is the biggest. We got about 12 to 13,000 fire detectors on site.
13,000 fire detectors?
Yeah.
Okay, wow. And that's coming all into a PcVue application. Can you tell us a little bit how that application is built in terms of redundancy, communications, servers and all that?
Yes. So, well, first of all, it was the PcVue application was designed almost, the one we're using now was in the year 2000. So that was the initial concept of it. So we started in version 7 something and had evolved ever since. But the system is not a control system of such, it's just an alarm system. We use some of the concepts from a real SCADA system also, but the base is an alarm transmission system. So its main goal is to make sure that an alarm somewhere in our complex arrives at the fire brigade. So we have several layers of transmission. So we have what we call hardware alarms. So CERN is divided into 34 safety zones. In each zone, we have 2 PLCs that collects the data. So we have hardwired inputs into a PLCs. So in each zone, we have 2 PLCs that does exactly the same. They read the same input and transmit them via 2 different TCP/IP networks to the PcVue servers.
So that's your first level of redundancy, I guess.
Yeah, so we have redundancy in the transmission path. We have redundancy on the server level. PcVue allows to have redundant acquisition servers. It's also PcVue that controls which PLC. There is always one PLC that is read and the other is still transmitting alarm, but it's PcVue that decides which one it will read. So if it loses connection to one PLC, it automatically switches to the other. That is a native functionality of PcVue. So the whole acquisition chain is redundant. All equipment in principle are redundant. So we have 2 operator stations with 2 screens, 2 power supplies for PLCs, for everything. So we have in reality, we have 3 separate transmission paths for the data, because we also have a hardwired path. So the PLC activates an output that is hardwired directly to synaptics in the fire brigade. This is, at the time, was a requirement for nuclear installation. They don't like purely computer-based safety. They like wires. Yeah. So we have a fallback option, which is a wired. So we can actually run the system without, if all the computers go down, all the PcVue servers go down, the fire brigade can still operate the system, of course, in a degraded mode, because they don't have as much information, but the system is designed to be running even if the computers goes down. More or less at all the levels. And then on top of that, so this is the hardware alarms, which is, I think we have a couple of thousand of those. But on top of that, we have what we call software alarms. That's where we connect to the fire detection centrals, to the gas detection centrals via different protocol like OPC UA. So in the last couple of years, we migrated everything to OPC UA. And that's where we have around 30,000 alarms of that type. And that's another layer of transmission path also. So in reality, for one alarm, the fire brigade will have 3 alarms arriving in the control room, but they should react the same no matter if it 1, 2, or 3 that arrives. It's all about redundancy.
Right, I can imagine, especially for critical applications like fire detection and all that. What's the protocol between the PLCs? You didn't mention OPC UA, but what's the PLC type and protocol that the PLC uses?
Well, we started originally with the Schneider Premium. And we now, a couple of years ago, we migrated to what's called 580, the new model of Schneider. Yeah. Again, it's a standard PLC. It's not a hot standby, whatever. So it's completely off-the-shelf PLC. So we talk Modbus with PcVue.
Okay.
But as I said, there's 2 PLCs in each zone, and we have 34 zones. It's a lot of PLCs that we have. In the end, the premium was not supported anymore, so we changed it all. But that was a big investment on the PcVue side. It was relatively pain-free. It was relatively transparent as long as we mapped the data to the same, so that didn't cause any problems.
Okay. You mentioned tens of thousands of data points. That's a lot of information. How is that displayed to the operators? Do they have a huge mimic in a control room somewhere where you have the status of the fire systems or individual? How is that displayed? How do you manage displaying such a large amount of information to the operators?
The main screen they have is an alarm screen, completely classic, where the alarms will appear one after the other. They have an overview. We have static views of the side of the safety zones, so they can see which buildings are affected by fire. But that is one of the problems we've had, is that we have such a big site and there's so many changes all the time. There's always work going on, that to make synoptics which are precise and up to date is almost impossible. So we have until recently stopped at the building level, just saying there's an alarm in this building. But at the same time, PcVue we capture a lot of analog data, because in our underground areas, most of our fire detection is remote, in the sense we cannot place a fire detector next to the accelerator because the radiation will destroy the electronics very, very quickly. So most of it is where we have a tube. So we pull the air with a pump and analyze for smoke, and then pump it back to where we took it.
Like a gas.
Yeah, it's It is a fire detector, but we just suck the air in from a long area and analyze it somewhere else where we are protected from radiation. And of course, this airflow in these pipes, we monitor for if there's a break in the tube or if some of the holes where we measure has been clogged up. So there's a lot of analog measurements that goes to PcVue also. I would guess we have around 3,000 analog measurements from gas detectors, fire detectors. It's a lot of data that we store.
Interesting. Yeah. And what about a lot of applications nowadays make use of mobility, so people can have data on their phones, their tablets. Has that been integrated into the system, or are you more traditional fixed stations in the control room or in various places?
Until now, we've been very fixed, mainly because we have two different networks. And we are reluctant to open it up like to a general purpose network because of cybersecurity concerns. But we are developing a mobile version, a mobile display they can run on a tablet. And that is also some of the developments with PcVue with a higher focus on cybersecurity, where I think we can obtain something which is safe and flexible enough that they can use it on the go.
Good. All right. Thank you very much. You did talk about the size of the applications. I would say, what would you say is the biggest challenge in running such a large mission critical project? Because you've got a lot of data, you got dozens and dozens of PLCs, redundancy. What's the main challenge of running such a large application?
It is keeping the configuration correct. I would have to say we got very strong procedures. I could get into the everything that we have is stored in a database. So our application is not it's not a classic PcVue application where it's static. All our data is stored in the database and generated. The configuration files for PcVue is generated from the database. Okay. And we have application where, because I don't declare new alarms on the system, we have an interface where the alarm responsible can declare their alarms. They are transferred to our database, and then they are applied once a week to the operational system via this database. That is quite unique, that we don't do anything more or less in the application. We use the application for debugging to see our configuration, but we don't have any static. We have a few, but 98% of all the variables in PcVue are generated from the database. And we do that to have control about what is the version of the data we have, when was it applied, and we can also always roll back. And so when we generate the configuration for PcVue, we could generate the complete configuration. So if we restart the servers, it will take those files and apply them. And we also generate what we call delta files, which is the difference between two generations. So what are the variables that have been added or removed since we last configured the system? And those variables we can apply to the system in runtime. So we don't have to stop the system to apply modifications to the system. So the whole chain is based on very strict processes that makes it that it's still sometimes a struggle, but we have everything centralized and very structured so that we keep on top of it. Yeah, but it is, we have 140, 150,000 variables, so it's still a lot, but most of it is automated. So there's very little human interaction directly.
No, I can definitely see the advantage of using a database to manage the creation or the spawning of the whole PcVue application. It makes total sense versus going to the editors of PcVue to add, remove, or change.
Yeah, I can say we have on average, it's up and down, but on average during a year, we have about 100 modifications a week. So either 100 alarms that are removed, added, or modified. So you need something which is flexible and you can control because it changes so often.
Yeah, okay.
It is designed as a system which is highly safe and highly flexible, which doesn't always goes together. But in our case, we managed to find a middle path which works in both directions.
You did mention in one of our discussions that you had some SIL level certification in the system. Can you talk a little bit about that?
It wasn't externally certified, but when it was developed with a contractor, so we had a contractor that developed most of it for us. The calculations were done to prove that we had SIL 2. We obtained the SIL 2 requirements. All the HACCPs calculations and the failure tree was done on the whole system, and we proved that it was SIL2. We are actually maybe a little bit better because the SIL2 calculation was only done on the PLC path, and now we have the OPC path on top of that. But it uses the same network as one of the other transmission paths, so it's a bit negated. But yeah, it was the goal of the system was to get it to a SIL2.
What were the main challenges, you would say, for somebody that's listening to this podcast and would like to have the same type of certification? What would you say would be the biggest challenge or the most important thing to plan out in advance to achieve this?
It is you have to think about it from the get-go. It's it's very hard to start designing a system and then later in the process saying, oh, it'd be good to have it a SIL2. You really have to think about the basic concepts from the start so that the whole design that you end up with is built on a structure that fulfills those requirements. So it is really, as many in development say, it's all the groundwork is the most important. What you do once you start doing the application, actually getting something up and running, that's the easy part. It's the design phase, which is the important one.
I can imagine. You have a huge site in terms of the geographical area, not only in terms of quantity of variables. You did mention 140,000 variables, but it's a large site.
Yes.
I think we have talked about you're using a GIS system or a positioning of the data. How is that built in? How does it look like essentially when I'm looking at the system?
So this is a development we're currently doing. As I mentioned earlier, we had these issues with synoptics that was never views that was never up to date. We could never assure them. So at CERN, for many installations, especially for all safety installations, when they're done, we are the AutoCAD files that are created when the system is installed. The position in the GIS are automatically created. So when we have new fire gas installations, the position of detectors are automatically put into GIS. So some years ago, we thought, okay, we have the views, the GIS views of the CERN site. We have the position, so why not use it in the application to show the precise location of each detector? So over the last year, we have been developed that, and I actually did just a reception test the other day with the fire brigade, and they're very happy. So now when an alarm arrives on the alarm screen, the operator can do a right click to get the actions, and there's open in GIS, and it will open the GIS view centered on the detector that is in alarm, and the detector that is in alarm will be flashing red. So it's very convenient, very easy for the fire brigade to get the information that they need, because they had the GIS before, but they would take the name of the detector and then type it manually into the GIS to get the position. And now we have integrated everything into the same application. So that's a big step forward. And at the same time, we generate the position because it's markers in PcVue, these detectors that's on the map. And it's all generated automatically on the database. So the GPX files for the map is generated on the database. We get the data from GIS. We generate the position of the markers. So again, we don't do anything manually. It's all automatic for us.
If we switch to the fact that you've been using PcVue for, like you mentioned, over 20 years, you went from version 7 initially, you updated as the releases were on. What would you say would be? Can you describe the relationship you have with PcVue? Because I'm sure the people behind PcVue have been assisting and giving you support on all the releases. Can you talk a little bit about the services part of a PcVue offering?
No, we have a close relationship with PcVue. Many of the people that was there in the beginning are still at PcVue, and we have known them for more than 20 years. Of course, I would say for basic problems, we use the support lines of PcVue. But when we have special requirements, for instance, this GIS development, I talked to the salesperson that we've had for many years that knows our application very well, knows CERN very well, and expressed this need that they have. And this functionality with the GIS view was then developed in the version 16 release of PcVue, so it was integrated into that. So I would say that we have a long, mature relationship with PcVue because we have a long history, but they also listen to what are our needs. Of course, they can see it will benefit other clients, but we have a I think, a very good relationship. Also, when we have issues or when we migrate to a new version, I can talk to people more or less directly, not the developers, but via our commercial contracts or contact or via the technical contact. So I've been very happy with the relationship we have, and it's one of the reasons after so many years that we're still using PcVue, because it works and we have a good relationship with the supplier.
I'm glad to hear it, because you're right. It's one of the important vision that PcVue has, is to be very close to, especially large applications that have very specific requirements, such as yours. You're kind of a showcase application, I would say. PcVue prides itself on being there for the integrators and supporting. And if new developments, like you mentioned, arise, for sure, if it's something that others might benefit from, they get integrated into the product roadmap. So I'm glad to hear that. What would you say would be your vision on the evolution of the PcVue application you have right now? Do you foresee adding some new features, or what if you project yourself, let's say 5 years down the road, what would you add or change into the application?
It's a hard, things move so quickly at the moment, and even like the new requests that we get, it's hard to say where we're going. Of course, one of the trend is cybersecurity. We cannot get around this. So this is, whether we want it or not, it's just something we all have to deal with. So I appreciate that this is something which has been taken serious by PcVue, and it's developed in a direction that takes cybersecurity into account. Of course, the big thing for the last many years has been machine learning and AI. It is in our applications maybe not that easy to do it or to see the benefits from it. But what we have had actually for a few years is that we collect all this data about analog, like temperatures, airflow, and we have all this data pool of data. And one concrete example that we've been working on is like the airflow in these pipes where we do the fire detection. They're very dependent on like the ambient pressure around it. So if somebody opens a door and you have a big airflow, of course it will affect the measurement of the airflow in the pipes. Mm-hmm. And it will actually generate a fault for the technical control room, saying there's something wrong with this airflow. But instead of just having an alarm threshold for it, then having some kind of AI module that would learn that a peak like this, like a sudden peak, and then it goes down to a normal level, is a normal, something that can happen, and it doesn't necessarily have to activate an alarm for this event, even though it's gone over the alarm. So this is the kind of things that we're looking at in order to reduce the number of interventions from the on-call service during the night or whatever. So trying to remove as much as possible of what we call like noise for alarms, which are, it's a real alarm. You cannot say the measurements went over the alarm threshold, but it went down again straight away. And an AI could over time learn, we could train it to identify which events should require an intervention and which requests. This is technical alarm. And when we're talking about intervention from the fire brigade, they will always go. There's no discussion. If there's an alarm, they will go. So we will not apply any kind of filtering on that. But on the maintenance side, we have looked at this for a long time.
And talking about maintenance, interesting, because you've got so many components in your in this overall applications. Do you integrate PcVue with, let's say, a maintenance management system? Let's say you have more alarms on a specific area or equipments. Will you trigger tickets in the maintenance system, or is PcVue pretty much isolated with no integration to other systems?
It is very much isolated. Okay. One of the requirements at CERN is that each, what we call alarm level 3, so each alarm that goes to the fire brigade, have to be tested once a year. If you say we have 13,000 alarms, you can make the calculation how many alarms we generate a day. What we are also implementing at the moment is that in modern fire detection sensors, gas detection sensors, they have a maintenance mode, which means that it's not the same alarm which are generated when in maintenance mode that is the real alarm. So actually in the future we will, when the technicians put the central in maintenance mode, of course we have a lot of security about when they can do it and to avoid they leave in maintenance mode. But then we have different alarm screens on PcVue. So when the maintenance alarms is activated, they will go to the maintenance console in the workshop of the maintenance people of the fire, and they will not be seen by the fire brigades. So we will try to reduce the number of alarm caused by maintenance sent to the fire brigade. But again, because it's a SIL2 system, we have been reluctant to actually change the level or whatever the alarm in PcVue. So we have decided to do it on the ground level, so actually at the actuator level in the fire detection centrals. But again, we have different screens, so each alarm can go to a different screen. So it's things that we work on.
Sure, yeah. I guess with so many alarms, you have to have zones and ways to segregate and present the alarm in a manner which is understandable or readable by humans, I guess.
Yeah.
Thank you very much for your time. I'm looking forward for the next few years where this impressive application will grow at such a, I would say, such a prestigious site, which is the CERN. Anything else you want to tell our audience before we conclude?
No, but I would just say we have next summer, so in 8 months, we will shut down for a long shutdown. So we will be installing what we call the HS LHC, so high luminosity LHC. So we actually, in certain places, build new tunnels alongside the old ones. So there we will have a lot of new alarms to integrate. But also in those 2 years, we will not be running. So there's possibility to come and visit the site if people are interested.
Oh, that would be very interesting. So you'll be pretty busy, I guess, with these new installations, I guess.
Yeah, but like publicity is part of our work also. So we always have visitor groups.
Well, thank you very much for your time, Henrik. It was much appreciated.
You're welcome. It's been a pleasure.